Finding larger angles in trigonometry with adamonlinetutoring. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. In GCSE maths, trigonometry is not just for right angle triangles and angles less than 90 degrees. You extend sine, cosine and tangent to angles greater than 90 degrees up to 360 degrees and sometimes beyond. To answer the first question, we need to find all of the values of x in the range 0 to 360 degrees for which sine of x is equal to 0.36. To think about the different solutions within this range, it will be useful to sketch the graph of sine x between 0 and 360 degrees, which looks like this. If sine x is equal to 0.36, I can use the inverse function to work out my principal value for x. This will be the main angle solution provided by my calculator and is typically a value between 0 and 180 degrees for inverse sine. Using my calculator, I get a solution of 21.1 degrees, but this is not the only solution. Drawing a horizontal line across to represent y equals 0.36, I can see that there is more than one solution within this range. The principal value my calculator has provided me is this one here of 21.1. There is another value this side of 180 degrees. Notice the curve has a line of symmetry about 90 degrees, so a distance of 21.1 away from 0 will be the same as a distance of 21.1 away from 180. So I can find my other solution for x between the range by doing 180 minus 21.1. which gives me another solution of 158.9 degrees to one decimal place. For the next question, I need to find all of the values of x in the same range for which cos of x is equal to 0.26. Again, I'll start with a sketch, but this time of cos x. Cos x looks like this, and if cos x is equal to 0.26, I can use my inverse function of cos to find my principal value, which is the main angle solution and is typically between 0 and 90 degrees. X is equal to 74.9 degrees to one decimal place. Drawing the line y equals 0.26 is roughly here. My calculator has given me the principal value of 74.9. Notice with the cosine function, there is some symmetry of the curve, but around 180 degrees instead. So the distance of 74.9 from 0 will be equal to the distance of 74.9 from 360 degrees to find the other solution between 0 and 360. So this can be found by doing 360 minus 74.9. So this other solution would be 285.1 degrees to one decimal place. For the last question, I'm finding all of the values of x in the same range for which tan of x is equal to negative 2.7. The graph of tan x looks like this. If tan x is equal to negative 2.7, my principal value can be found by doing the inverse tan function of negative 2.7. This gives me the main angle solution for inverse tan, which is typically between negative 90 and 90 degrees. Using my calculator, I get negative 69.7 degrees. The principal value is actually outside of the range for the sketch that I've drawn. It would be further to the left-hand side, giving me a negative solution of 69.7. But due to the periodic nature of these curves, which describes how often they repeat, in particular tan, solutions repeat every 180 degrees. So even though my principal value falls outside the range, I can continue to add 180 to find solutions inside the range, like 110.3 degrees, which will be this solution here, and then adding another 180 degrees to give me my last solution in the range of 290.3 degrees. On to the intermediate questions with an increase in difficulty. Find the exact value of sine 150, and we need to do this without using a calculator. I can start by sketching and considering the graph of sine 150 would be around here. If I extend a line up to the curve and draw a horizontal line across, which helps me to find the other angles that give me the same value, the value for sine of 150 would be the same as sine of this other angle. Remembering that the sine function has some symmetry with its curve about 90 degrees, So the distance that 150 is away from 180 will be the same distance that this point is away from 0. So working backwards from the beginner questions, 180 minus theta was equal to the other solution of 150 degrees. Therefore, taking 180 away from both sides to give me negative 30 and multiplying through by negative 1 would give me theta as 30 degrees. Now that I have the principal value of 30 degrees, I can use my knowledge of exact values with the diagram shown. Sine of 30 is equal to the square root of 1 over 2, which is the same as 1 over 2 or a half. Sine 30 being equal to a half means that sine of 150 is also equal to a half. For the next question, I'm doing the same thing, but for cos of 300. Starting with a sketch of the cos function will be helpful, which looks like this. Extending a line up from roughly 300 will be around here, and then extending a horizontal to represent the value of sine 300 so that I can identify some of the other angles which would give me the same value, such as this one here. Remembering from the beginner questions that the curve within cosine involves some symmetry about 180 degrees, so the distance that 300 is away from 360 will be the same distance as 0 from this corresponding angle. When we had the principal value, which was the first one, we would typically take this away from 360 to give me the other value of 300, taking 360 away from both sides to get negative 60 and timesing through by negative 1 would give me 60 degrees. Therefore, cos of 300 will give the exact same value as cos of 60. Then I can use my diagram along with my knowledge of exact values to find cos of 60, which is the square root of 1 over 2. So cos 60 is also a half, which means that cos 300 is the same value and is also a half. Lastly, we'll do the same, but for tan 240. Sketching the function for tan looks like this. 240 will be roughly here. Draw a vertical line and then a horizontal to show any other angles which would give the same solution, like this one here. Tan has a periodic nature where it repeats every 180 degrees. So like the beginner questions, if we had our principal value, which in this case we don't, it's labelled as theta, we would have added 180 degrees to find my other values, such as 240. So applying the inverse and taking away 180 would give me the principal value of theta, which is 60 degrees. Therefore, finding tan of 60 degrees will give me exact same value of tan of 240 degrees. To find tan of an angle, using my diagram for exact values, I need to use the identity of sine over cos. So working out sine 60 and cos 60, sine of 60 would be root 3 over 2, and cos of 60 has already been worked out on the previous question and was the same as cos of 300, which is a half. Since tan of 60 is equal to sine of 60 divided by cos 60, I can do root 3 over 2 divided by 1 over 2, and using keep, change, flip, this will be the same as root 3 over 2 times 2 over 1, which gives me a value of root 3 over 1, which is the same as root 3. On to the advanced question, one of the trickier questions that you're likely to find on this topic. Find the size of the obtuse angle labelled W, correct to 1 decimal place. Obtuse implies that the angle is between 90 and 180 degrees. I'll calculate the angle as I would normally and see what happens. I'm working with a non-right angle triangle where the question involves two pairs of opposite angles and lengths, where one is unknown to be found. This means I'll be able to use the sine rule to help me find the angle. I want to use the version of the formula where the angle forms part of the numerator. So sine of W over the opposite length of 52 is equal to sine of the other angle of 21 over the opposite length of 41. Multiplying both sides by 52 and then applying the inverse sine function will give me the angle W, which is equal to inverse sine of 52 multiplied by sine 21 over 41. Typing this into my calculator gives me an angle for W of 27.03 degrees. The problem is, this angle of 27.03 degrees does not fit within the criteria of being an obtuse angle. It's currently an acute angle. I need to find sine of a larger angle than 27.03, which will give me the same value. To do this, I can consider my sketch of the sine function. The angle of 27.03 will be roughly here. Extend a vertical line and then a horizontal. You can see that the same value is achieved using this larger angle. Remembering that the sine curve has some symmetry about the angle 90 degrees, so the distance from 0 to 27.03 will be the same as the distance from 180. 180 minus 27.03 is 153.0 to 1 decimal place, meaning that sine 27.03, which was our original answer, is the same as sine of 153 degrees, which now fits the criteria of being an obtuse angle between 90 and 180 degrees, and therefore our final answer is 153 degrees. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are and write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.